Hello, good morning, or good afternoon, or good evening. So, welcome to today's talk. Today, we're going to talk about Lambda functions. As we all know, Lambda functions are famous, or they are known for their for building scalable applications and event-driven applications. So, today we're going to see how we can put Rust in those Lambda functions, how to compile Rust for the Lambda function, how to deploy Rust code in the Lambda function, and how we can debug that Rust code and debug that Rust code locally, as well as how we can debug that Rust code in the cloud itself. So for today's talk, I may need some prerequisites. And before that, I'll talk about what we are going to demonstrate today. So this is our a normal cloud setup uh, in our AWS cloud. So of course we need a free version or a free trial version of AWS cloud. So in that we'll need an S3 bucket. We need EC2 instance running. It should be an Ubuntu instance. A T3 micro instance will work for us. Then of course we're going to spin up a Lambda function, and also will require an AWS secrets manager. We'll store our private key for accessing the EC2 instance. So make sure that there is file available in your S3 bucket. Make sure that you have your private key for EC2 instance added in your secrets manager, or else I can also demonstrate how we can add the private key to the secret manager. And of course, the EC2 instance must be running. Then we'll see how we can add the Lambda function. So this is my AWS account, and this is the dynamo table. But yeah, okay. I'll go to EC2 instance. Yeah, EC2. Sorry for the background noise. There is some work going on at my place. So yeah, these are my two EC2 instances. We're gonna use any one of them. You can use both are T2 micro Ubuntu instance. And so to get started, we'll first look at what all things we'll need on our AWS cloud. So this is my AWS cloud instance. Um, I have created two EC2 instances. We will need only one EC2 instance for T2 micro. Just make sure that the RAM size is decent enough. Like you can choose between 16 GB or something like that. Because what I faced is I created the first EC2 instance and I was not aware of the the load which it's going to carry. So I've created with a minimum possible RAM because to not to get involved in any billings and all those things. But you can get that expanded up to 30 GB, I guess. So make sure that you get your IPFS or your EC2 instance with a decent RAM size, so that it would be easier to compile our Rust code and all those things. And then we will need an S3 bucket. So yeah, this is an S3, which is simple storage space for storing any kind of files and all those things. So what we are going to do, this is this bucket I have created, and this bucket we're gonna use Anand bucket 2109, and we'll be going to pull this file in our Lambda function and put this file into one of the EC2 instance. So we're gonna pull this file rustput.png, and we're gonna put this file into the EC2 instance. Then we will need a secret manager. So AWS provides us uh, the way to store our secrets. So why do we need this secret? Because first of all, I'll tell you why do we need. So our EC2 machine in order to connect to our EC2 instance, here if we just open this one. So let's say I click connect, and we need this IPFS or whatever is the private key file. So if I copy this command, I open a terminal here. I'll go to downloads, and here if I do ls-l, let me do ls-l grep IPFS, or maybe star.pm. Nothing is there. Then let's see IPFS. Yeah. I'll increase the font size maybe. So see, this is my private key file. If I do here cat, now this I should not be doing, but since I'm not doing any critical work, so I'll show you my this. This is the private key which will be going to use in order to access our EC2 instance. Now what we have to do, we have to make this private key available to our Lambda function. Now in order to do that, we'll utilize this secure manager or secrets manager. Yeah. So we go to secrets manager. We there's already a test created by me. So this is our secret manager. Here we can add the value. Like for example, uh, let me change my location to, let's say, Asia Pacific. So here is my production grade. Yeah, this is my secret key which I'll be going to use in my Lambda function to get the value. So secret value is being stored here. If you click on retrieve secret value, it will show us the secret value. I have stored this secret value in the plain text format. So just copy this string, and you can store that string in the plain text format in your secret value. And when we going to retrieve this value in our code, it will give us that particular private key. Okay, now let me see if I have covered everything. So S3 bucket I have covered, EC2 instance, secure storage, and yeah, of course, Lambda function will be needing. But for Lambda function, we'll be utilizing most of the things from command line only. So if we see here, I have two Lambda functions available. Like this, the file upload EC2. This is what we are going to demonstrate. So let's get started. Yeah, and before beginning, we need some tools to be installed. So we need Cargo Lambda to be installed on our Linux machine. So to install Cargo Lambda, this is the site which I have followed. This is the Cargo Lambda installation guide. Here, the very straightforward thing is if you have Python 3 installed, you can directly install it using this pip3 installed. I have done the installation using pip3 only. Just follow the instructions. Cargo Lambda will be installed. So Cargo Lambda will help us to generate a template for the Lambda function with all the dependencies. Like we do cargo new test 1 2 3. In the same way, we can do cargo Lambda new my Lambda function, and it will create. It will ask you what kind of Lambda function you'll be needing. In this case, we are going to use an HTTP function. Yes, and currently I'll say I'll trigger my Lambda function based on the function URL. So it has created my new Lambda function. So we can go to my new Lambda function, and here we can open the code. Yeah. So this is the template of the Lambda function. We will get directly the template if we use the Lambda tool. Otherwise, we have to copy lots of things from here and there and make sure it is working. So Cargo Lambda helps us doing that. And also create a very basic template. Let's go on to dependency section first. So We are going to use Lambda runtime, which is the AWS SDK. I'll show you which one we are using. Yeah, this one. We'll be utilizing most of the things from AWS SDK Rust. It has lots of example for all the things which we are going to, all the things which are available in the cloud. For example, it has EC2 examples, then it has Lambda examples, and secrets manager also it has examples for. Yeah, this is secret manager. So what we have done, we have combined all these things and we have created a small project which I have shown you, and we'll demonstrate and we'll debug and demonstrate that project. Let's start looking into the code now. So we'll create an empty function or hello world function using our command. I'll go one step back, execute cargo lambda hyphen new hyphen http, because we are going to create an http function which will be going to be triggered from the URL of the function. Let's say what name should I give? Let's say my lambda function, or let's keep it my lambda. We'll go to my lambda. Okay, and we'll start code here. So yeah, we'll get the hello world template for http lambda function with the dependencies. Here we are going to use Tokyo as a runtime because all the functions are async function here, and we are going to use lambda http and lambda runtime crates for deploying and creating our lambda functions. So let's get some let's put some code to this thing. So this is my already existing code. What I'll do, I'll just do Control C and I'll paste in our new lambda function so that we can see how we can compile and debug our new lambda function. I'll get the dependencies as well. So what all things we have added here? Let's get started with first the AWS config. Now this is the crate for configuration. Whenever we want to debug or whenever we want to start our lambda function, and if lambda function wants to access any entity, for example S3 bucket or secret manager or EC2 instance, so it will need a configuration first of all, like what is my configuration, what which Amazon account or which AWS account entity I have to fetch. So this config crate is for that. Then SDK secret manager is for interacting with the cloud secrets manager, to retrieve the file, or if you want to create one more secret, we can create using this. S3 is for interacting with the S3 bucket, and a lambda HTTP is for our run is for creating and deploying a lambda function. SSH2 crate we are utilizing because we need to do SSH login to our EC2 instance. So whatever EC2 instance we have created here, if I go to EC2, will be logging in as a user from the lambda function. So this is my instance, and if you want to connect, so this is the SSH. It has I have kept SSH port open. Of course, we have to keep SSH port open for that EC2 machine in order to access it via SSH. Then we have OpenSSL dependency for um, for this thing. What do we say? For validating and authenticating the user with the private key. Then Tokyo is the runtime for us, and Lambda runtime is runtime for the Lambda. So let's walk through the code once. We have defined some constants here, like region. Currently I'm using Asia Pacific South, that is Mumbai region, and bucket name is my bucket name which I have already created manually. So this, let's just ignore these things, and we have to cross compile this thing. That's why there are some Rust analyzer errors coming up, showing up, because this code is not meant for this particular target. It is meant for the Lambda. That's why the analyzer is not happy with it. So in the main function, we are directly calling run with a closure with the service function, and it has a closure with request, and which is calling our handler. So this is the handler function which we have defined here. It accepts body and or it accepts nothing and returns a body. So let's say what is, let's see what is in it. Let's look into the our code. So regions provider will provide the region for the configuration. So the region we have defined here, the string we have to pass to this function, and then we have to create the configurations with AWS config from environment. So what this will do, it will create the configuration from our local environment. If we are running this function locally, or we are debugging this locally, so it will get the configurations locally from our local computer, from this file which is already stored, cd home. See, if we do ls here, there is a .aws file. We go to cd.aws. Here is the credential file and config file which is stored here. So when we install AWS CLI or AWS client, it automatically creates this particular file for us, and this function will take the credentials from that particular file. Then we are initializing the S3 client with this particular config which we have created, and object key is nothing but our the file name which we want to retrieve from the S3 bucket. So here we are reading the file from the S3 bucket and then converting that particular file into bytes here. Then we are getting the private key from our secrets manager. So this is the function defined here. This will also need the configuration. So I have passed the SDK config which we have created earlier here only. So this config we can pass it here, and then we define our secret name and create again secrets manager client and get the secrets value out of it. Once we get the secret value out, we need to read the secret string and return the secret string, that is private key here. So we get the private key here. We'll print our private key. Then in the EC2 instance setup, we need to provide the details of our EC2 machine. So this is our public IP address or public domain for our EC2 machine. You can find it here easily. Here is the public IPv4. Then username is Ubuntu default. Then path. This path is the path of the file or path of the destination where we want to keep our file which we have fetched from the S3 bucket. So currently I have kept straight away home, Ubuntu, and Rustboot. Let me change this to upload, uploads and Rustboot dot. So it will go to uploads folder and it will put rustboot.png. But you have to make sure this upload folder should already be present in our EC2 machine. Then this is our code to upload a file to the EC2 instance. So we are, first of all, we are creating the TCP stream. Then we are creating a session, SSH session. Then we are doing a handshake, and we are finally authenticating using the pub key. So this function requires username and a private key, whatever we have extracted from the secrets manager. We can also do this by using, if we have the private key file, we can also do this by using this function dot user auth pubkey memory, not user auth pubkey file. So instead, in this function, what we have to do, we have to give username and path of our private key file. But as this function is going to run on the Lambda, so Lambda does not have any file system as far as this project is concerned. So we have not created any local file system for Lambda, and that's why we are going to pull the private key from the secrets manager, and that particular string, private key string, we are passing to this function. So that's why we are using user auth pubkey memory. Rest of the arguments are optional. We can pass them none. It will evaluate on itself. So once this function is being done, we are successfully logged into our EC2 instance via SSH. Then we are setting up SFTP for file transfer, and here we are creating the new file with this path. This path is nothing but here whatever we have mentioned, and we are writing all the bytes which we have previously read from here. And once this line is being executed, our file will be present in the on the EC2 machine. Now this code is to upload that particular file to IPFS, but I think for time being we don't need this one. So what we'll do, we'll remove this code, and this is the response which we have to send back to our main function, so that we can get some things on the string. So here what we'll put file created and channel exit status we don't want. We'll say file created, and if you want to print anything we can print here also, but let's keep it simple. We'll just print only one statement. Okay, then let's compile this thing. So for compilation, you need to add this target cargo, or maybe rest up target. Let me do rest up show. So for compilation of our, or for cross compilation, we need this target to be added. So I have already added this target. You can add this using rust up target add. We all know how to add that. Okay, rust up. Let me demonstrate. Target add x86 underscore 64. Non Linux musl. So it is already up to date. You can add this, and then we need to compile using cargo. Let me clear this. Cargo lambda build release, and we have to also define the target. The target is x86 musl. You can hit enter. Yeah, it will compile the code for us. Meanwhile it is compiling, we'll see, or we'll create one, we'll connect to the IPFS instance and we'll create one uploads folder in that. We'll see if it is already created or not. So let's connect our instance from here only, see if it is connecting. Yeah, it's been connected. So we have to create uploads folder. I guess I have already created here. So uploads is already there. We go to uploads. Here if we do ls, is this thing visible? I'll do clear and again I will do ls on l. So here you see we already have rustboot.png. What we'll do, we'll remove this rustboot.png. So rm rustboot.png. Now if we do ls and l, see rustboot.png is removed. Now we'll execute our function and we'll add that our function will add our rustboot.png file here. So let's see if this has been compiled. Yes, it will take some time because as heavy libraries are being compiled here, Tokyo and AWS SDK and all. So in order to deploy our function, I'm following this particular blog. It's a very good blog which demonstrate or which clearly tells you how you can deploy cargo or a lambda function using cargo using this cargo lambda deploy. Let's see, yeah, it is compiled and it is finished. So if we go to target, go to lambda, we have our bootstrap code or bootstrap file. Now we will deploy this particular code to our AWS instance. Now in order to deploy this, we'll follow this thing and or first of all we'll do local debugging of this. So what I'll do, if you want to debug this function locally, you can add some print statements here. So here, like for example, I've added println. Then that's all. I guess here also we'll add one println, and it's a macro. And here we'll add that file added successfully. Okay. Now what we'll do, we'll cargo lambda watch. So what this thing will do, it will invoke or it will spin up the function locally at this particular port. So if we go to our browser and we type localhost and 9000 and then you have to type lambda URL and the name of your function. So the name of our function is my lambda. So we'll remove this one and we'll add my lambda. So see, once we hit that particular API or we hit that URL, these things get compiled. These things will get this will start compiling itself for each invocation. So now, since it's been already been compiled, it should not take much time, and we should get some print statements out of this. Yeah, it's done. Yeah, see, it has printed our the first thing, println the private key. Here it has printed our private key, and at the end, is not being able to add our thing to this statement. Is not yet printed. Okay, we'll see what's the error here. I'll close this. So this is the way how you can debug this function locally. If there is some error or if there are some problems in it, you can debug it step by step. So as currently it is not able to access access the EC2 instance. So what I'll do, this particular statement is not been printed. So what we'll do, we'll control X and we'll add this statement here. Let's see if this statement is being hit. So I'll again start cargo lambda watch and get enter here once. So if the statement prints, then we are sure that this particular three commands file added successfully was hit. Now what we'll do, we'll add the print statement after user authentication. So for each change, it will compile the code. If there are error, it will throw an error. So yeah, it's compiled, and we'll again do argo lambda watch, argo lambda watch. We have invoked it, and I can hit enter here. So see, we have got the first print statement, and it's in the second print statement is also being executed. So the file has been added successfully. Now, if we go to our EC2 instance, if in upload ls, if we do, so bingo, yeah, we have got our rustboot.png file, and this file is from the S3 bucket. Previously, we have deleted it, and now we have again got our rustboot.png, which was from our S3, which is already present in the S3 bucket. So it shows our Lambda function is working fine locally. So our local debugging is successful. Now we'll deploy this particular code into our Lambda function. So yes, get back to our script, or get back to our website which we are following. Yeah. So while we deploy the cargo, while we deploy the Lambda function, we have to create a role for that Lambda function. So while creating a role, this role is nothing but an IAM role, that is identity access management. This role will make sure what all access our Lambda function will have. So in order to create this role, once we create this role, we have to provide the access to this role for S3 bucket, for secrets manager, and for our EC2 instance. As our Lambda function is going to interact with all these three things, we need to provide permissions to this particular role for this Lambda function. So we'll see. Yeah, so this is our Lambda function, and it is going to interact with all these three things. So we have to provide access for these three things to our Lambda function. Now here they have mentioned like how we can provide the role. So while creation of IAM role, we have to create whatever name we have. What We have to choose a name for our IAM role, and here they have created a Rust role. So let's start with doing that thing. If we go here, so I'll clear the screen first, and we'll follow the steps. So it is asking to echo our role. Let's just copy this thing and paste it here. We'll create some other name of role. So let's suppose lambda role, lambda rust role, something like this. Okay. Then we have following file. Yes. Then we will put the string into that file. Control C and Control E. Now, when this thing is done, then we have to do then we have to create a role, and for creation of role we need AWS CLI to be installed. Now, what is this AWS CLI? AWS CLI, AWS CLI. You can install this AWS CLI tool for your machine. So this is the Linux installation. Linux is straightforward. You can install this from here. Also, I have already installed that particular AWS CLI. Will directly execute this command. We'll copy this. This command is. Will tell you what this command is doing. Paste it here. We'll get this thing into one line. So AWS IAM create role. This will be creating a new role for us. Role name. We have to provide role name. So role name is our what we have decided. Lambda Rust role. We will assume, and the file name is also this one. Lambda Rust role.json. We hit enter and an error occurred. Thank you very much. JSON string must not have leading spaces. Where are the leading spaces? Okay. Here it should not have the leading spaces. Okay. Okay, fine. Now let's copy the ARN. The role is created. We'll copy this string. That is increase this thing to a bit. So we need to copy this complete string somewhere because we'll need it in the future. Copy and paste it in the notepad for time being. Then this part is being done. The next is to deploy the cargo to deploy the Lambda function. So in order to deploy, we'll use this command. Paste it here. What's happening? Okay, we'll close this terminal and we'll open one more terminal here. Okay, and here we'll paste our command cargo lambda deploy enable function URL and name of our function. So in our case, name of function is my lambda function, and also we need to specify IAM role. So hyphen IAM role and ARN of the role. So ARN we have copied here. This is our ARN. Copy this ARN, Control C, and we will paste it here. So what this function will do, this function will deploy our function name, which is lambda, and it will provide us the URL for that function in order to invoke that function. And then it will assign this particular role for our lambda function. So once we hit enter, it is deploying function. And here we have got the function URL. This is the function URL. We'll copy this function URL, copy, and let's paste it here somewhere. Let's paste it here. This is our function URL. Now what thing needs to be done from the Amazon side is we go to IAM role. IAM role. Here we must see the role which we have created right now. So if we go to roles, yeah, make sure you don't create lots of role because I've got a bill of few dollars because I've created some more than 30 roles in a month. So just make sure you're not crossing that limit. Lambda Rust role. So here is our role. Now currently it has no permissions, so we'll add permissions, attach policies. So first things first, we need to provide S3, and we'll provide Amazon S3 full access. No, Amazon S3, just click the checkbox, Amazon S3 full access, add permissions. Then what next? We need a secret manager. There is no policy with secrets. Secret manager read write access. Yeah, add permissions. So now we have S3 and secret manager. One more thing we need to add is EC2. EC2 full access. So for demo purpose, we are providing full access, but it depends on our application. So what all access we need to provide to for our Lambda function in the production. So if you want only to read access, we can provide that also. Or we can create our custom policy also. So as far as I am thinking of, we need these three access only. So yeah, let's go back to the roles and go back to the instance and just check if our Lambda function is being deployed or not. So if we go search here for Lambda, I should see now three Lambda functions. Uh, okay, let's go to another location. Let's check out Asia Pacific. Yes, see our my Lambda function is already present, and this is our function URL. Now we want to test this function from cloud as well. So what we'll do, we'll first remove that rust boot file from our EC2 instance. So we'll go to EC2 in the new tab. In the EC2 instance running, I'll go to US East Virginia because this is my correct instance. I'll connect to this. I'll connect from here only. Let's see if it is connecting. Okay, it's been connected. Now we'll go to CD uploads and we'll do ls-l and we'll remove rustboot.png. We'll do again ls-l. So as you can see, there is no rustboot.png file now present, and now we'll invoke our function from our function URL. So this is the function URL which we have copied. We'll copy the function URL and let's execute it here in the Thunder client. A new request, paste it here, and let it be get, put, or post. It doesn't matter. Send the request. Yeah, we have got the reply as file is being created. As we are returning from here, we go to main.rs. Here we are returning this string in the response. So the file is being created. I will check Amazon EC2 instance. We'll do again ls-l, and yes, the file is being created, rustboot.png. So our function is working on the cloud as well. Now this function can be triggered from different things. For example, let me go again to the Lambda. Now here I have only two Lambda functions. Let's go to our newly created Lambda function. This is my Lambda. So in order to add trigger, so currently what we have done, we have add trigger as our HTTP URL only. So here if you want, these are all the trigger options which we have. So what we have currently done in our project is we have triggered this Lambda depending upon any changes in the S3 bucket. So here you define the S3 bucket name, and here you put you can define or you can configure your trigger on the basis of what event you want. So if there is any put event, then this function will be triggered, or if some file is being deleted, then this function will be triggered. So in this way you can add different triggers to your function. And if we go to configuration, so here you can see our role. You must it's very important, because I have spent lots of time debugging in what is the issue, because there was an issue. There was my HTTP reply was it was throwing a bad URL reply. So later I found out that my role which I have created, it does not have sufficient mm, privileges or policies attached to it in order to access S3 bucket and secrets manager. So make sure that whatever role you are creating, the policies, correct policies is being attached to it. So in this way, we have discussed until now, like how we can debug the Lambda function locally and how we can debug the Lambda function on the cloud as well. So on the cloud, when that API is being hit, uh, this response is being thrown, this file created. So whenever we want to debug a particular code, we used to put this thing in instead ofeprintln, we need to provide this thing as a reply, as a response. So we are sure that our code is being executed till this point. We are sure that this particular command is being executed and this particular command is not being executed. So in that way we can debug our code on the cloud as well. So I think we, or whatever I have thought, I have covered all the things. We have checked S3 bucket, we have checked the product structure, then we have seen how to debug the program locally, and we have also checked how we can debug the program once it is being in the cloud. And we have seen how we can deploy the cargo, sorry, not cargo. We have seen how we can deploy the Lambda functions and using Rust. So I guess that's all. If you need anything, then you can contact us on this channel, or you can comment on this channel. We'll be happy to reply. And yeah, if there is anything else, then let us know. Also, I'll share whatever things, whatever the websites or whatever links I've been using in this video. I'll add those links in the description box. So yeah, thank you. Thanks a lot for watching. Have a nice weekend. Bye bye.